Electric eels have a secret weapon to generate electricity. Many people might cringe at the mention of electric eels, but what is it that makes these creatures such a shocking presence in the animal kingdom? Are they truly electric? And do they possess the power to deliver a jolt strong enough to stop you in your tracks? The science behind these aquatic hunters is truly fascinating. Electric eels are not actually true eels, as those found in the order Anguilliformes, which includes well-known species like the moray eel. Instead, these creatures belong to the Gymnotiformes order, also known as knife fishes. Despite the name of electric eels, their lineage diverges from what we typically imagine when we think of these slippery, elongated fish. In terms of physical attributes, electric eels bear a closer resemblance to carp and catfish, with their elongated, slender bodies and tapered tails designed for swift movement through the waters. This sleek form aids their hunting and survival in the dynamic river ecosystems of South America. A fully grown electric eel, native to the murky rivers of the Amazon and Orinoco Basin, can reach an impressive length of 2.5 meters or 8 feet and weigh up to 20 kilograms or 45 pounds, making them formidable predators in their environment. Unlike their marine cousins, which rely on gills for oxygen, electric eels are primarily air breathers, deriving around 80% of their oxygen needs by gulping air into their mouths. This fascinating adaptation allows them to thrive in oxygen-poor waters, giving them an edge in environments where other species might struggle. Living generators of electricity. Delving deeper into their anatomy, 3 unique organs nested within electric eels give them the incredible ability to generate electricity. Referred to as the main organ, the hunter's organ, and the sacs organ, each of these marvels of biology is packed with around 6,000 specific cells called electrocytes. The function of these electrocytes, they simultaneously discharge power when the eel feels threatened or when it launches an attack on potential prey. Electric eels are like living batteries. They have stacks of modified muscle cells called electrocytes, which have both a positive and a negative side, noted Dr. Rupert Collins, Senior Curator of Fishes at the Natural History Museum, London. When the cells are triggered, they discharge an electrical impulse into the surrounding water, making electric eels living, breathing generators of electricity. The shocking survival mechanism. One might wonder how an electric eel manages to generate such potent electric shocks without zapping itself in the process. The exact mechanism still eludes scientists. However, the predominant theory suggests that the water surrounding the eel likely absorbs most of the electrical current. Given that each electric discharge lasts only for approximately 2 milliseconds, it's plausible that the shock isn't long enough to harm the eel itself. Typically, the eels generate around 600 volts of electricity, but there have been instances of eels creating a stunning 860 volts, according to one study, while fatalities from electric eel shocks are exceedingly rare. Multiple shocks can trigger severe respiratory difficulties, even causing your heart to stop. Coupled with the possibility of drowning, coming face to face with an electric eel in open water could yield deadly results. If the eel doesn't get you first, the water might grasp you in its deadly embrace thereafter. Ecological role of electric eels. Electric eels are not just powerful predators, they also play a crucial role in maintaining the balance of their ecosystems. As top predators in the waters of the Amazon and Orinoco basins, they help control populations of fish and other aquatic creatures. By hunting with their electric discharges, they can stun multiple prey at once, efficiently capturing food while maintaining the equilibrium of the food chain. In recent studies, researchers have observed that electric eels may even influence their surroundings beyond hunting. The electrical fields generated by these creatures could play a role in deterring other predators, or even communicating with each other in the murky waters they inhabit. This interaction emphasizes their importance as not just predators, but as essential contributors to their aquatic ecosystems. Like and follow Science Risen to stay updated on your next electrifying science journey.